So today and tomorrow we're going to be talking about graphs of quadratic functions. This should be predominantly review, just maybe a couple new vocab terms for you that, to be real, I didn't even know were words until I became an IB teacher. They're just not taught in American classes. Again, we're talking about international mindedness, right? So here I've just got a picture of a quadratic for you, just reminding you of what the structures look like. So properties and facts, axis of symmetry always goes through the vertex. Hopefully that makes sense. I mean, the axis of symmetry has to go through the vertex. What that means, though, is that the vertex and the axis of symmetry always have the same x value. That's an important concept. The axis of symmetry and the vertex always have the same x value. Well, symmetry literally means, can be cut in half. So the axis of symmetry is going to cut the parabola in half. The number on the front, if you guys remember your in behavior stuff, or maybe even just some basic transformation stuff, the number on the front of the quadratic, the leading term, the thing that's in front of x squared, if it's positive, that graph goes up. Why? Because positive people smile. And if it's negative, that graph goes down. Why? Because negative people frown. Okay. So if the leading coefficient is positive, graph points up. Leading coefficient is negative, graph points down. The way this picture is shown here, we say that this parabola has a minimum y value. It has a bottom. It doesn't have a top, so it doesn't have a maximum. Of course, if it was a frowny face, you can tell I teach Gen Ed Algebra 2. If it was an upside-down parabola, then that vertex would be considered a maximum. It would be its highest y value. So none of that's new or groundbreaking. So we've got some different quadratic forms for you. The one at the top, this one here, jokes. This one here, this one's factored. So we call this intercept form. You don't need to know that terminology. I'm just letting you know that's intercept form. It's factored. It shows you the two places where that quadratic crosses the x-axis. And I did say two because, well, they would be different numbers in this format. They'd be p and q. If I gave you a quadratic in intercept form and you wanted to know where the axis of symmetry is, you could either memorize the formula, p plus q divided by 2, or you could just understand where it's coming from. It's literally halfway between the two x values. Okay. So rather than memorizing this formula here, I mean, what's the point? As long as you understand what was happening, you just went halfway between the x's and the y's. I mean, no, excuse me, the two x-intercepts. So on the far right there, what you have is how you find the vertex. It looks horrible when it's written in symbols, right? But here's what it says. Whatever you got right here, that's the x value you plug in to find the y value. That's all that says. So you figure out where the axis of symmetry is. That x is the x of your vertex. And if you want to know the y, you just plug that x in and see what you get. That's what this is telling you. Yeah, just plug that number in. That's all that says. Now the next one is still technically factored, but it only has one real solution. I mean, why would you write x plus 2 times x plus 2 when you could just write x plus 2 squared, right? So it has one real solution, and it's the place where this set of parentheses equals 0, obviously. That vertex would be on the x-axis. Bell is ringing. This is one where we say that it touches the x-axis. So this one up here, we said this one cuts the x-axis. When the vertex is on the x-axis, we say it touches the x-axis. And the nice thing about its vertex is the y value will always be 0, right? Because you're on the x-axis. Now this third one, again, you don't have to know the terminology, but this is vertex form. Vertex form is fantastic because it shows you the vertex. It also tells you all the transformations that were done, and we will get to transformations Unit 5. But it tells you all the transformations that were done. The vertex will always be h comma k, which is what makes the inside equal 0, meaning what would have given me a 0 right here, comma the number to the far right. That's where you always find your vertex, h comma k. And the one at the bottom would be your general quadratic form, ax squared plus bx plus c. This was the one that I asked you, I challenged you, could you use completing the square on it and see what you got? Well, what you got was the quadratic formula. And the quadratic formula being negative b plus or minus square root of delta, instead of saying all the other crap, all over 2a. Remember I told you that negative b over 2a part, that is your axis of symmetry. So when you have standard form, or general form, whatever you want to call it, the axis of symmetry is x equals negative b over 2a. The two solutions would be plus or minus delta, well, the rest of it, plus or minus delta, and then the negative b over 2a part, meaning plus or minus delta to the left and to the right. It's pretty cool. And once you have negative b over 2a, if you want the y value, just like before, you just plug it in. Hopefully it's not a fraction, because yuck. So that's about it for that. Now, all that is Algebra 1, technically. But we're good, right? Everybody solid on that stuff? I'm not thinking that negative b over 2a is, I don't think it's in your reference sheet. I don't think it's in your equation thing. I had to get the new one. Hopefully the new one has been published. So this one just says use axes intercepts, which is IB's way of saying use the x and y intercepts to sketch the graph. This is really, really simple stuff. We're just sketching the graph. He's sketching graphs, he says. All right, so we got picture not drawn to scale because who cares? We are going to cross the x-axis at -3 and +1. It's just a sketch. And we don't know the y-intercept, but we could find it very easily. What would I have to do to get the y-intercept? Plug in 0 for x. Yeah, buddy. So if we plug in 0 for x, what do we get? Y equals 2 times 3 times -1, which is -6. Picture not drawn to scale, like I said, because who cares? Yeah, that feels good right there. Cool. So we have a parabola that does something like this. And that will legitimately give you full marks on it. Well, he made a snorting noise, but what it does is it shows that you know what the two x-intercepts are, you know where the y-intercept is, and you are aware the parabola points up, and you're aware that the vertex would have to be lower than -6 and have a negative x value. Nope. You don't need to know the whole vertex. It just says axes intercepts. That is plenty. Do you have a question? Judging by eyebrows, Sophia, right? You looked like you might have had a question. That's the only reason why I asked. Okay. And we do the exact same thing for part B. Nothing's different, except for the intercepts and the fact that it's got a negative number on the front. Well, the negative on the front just makes it going to point down. Is going to make it point down, right? It's a good thing I don't care about online presence and sounding intelligent in my videos, right? Looks like we're going to cross at +1 and +2. Wow, okay. Picture extremely not drawn to scale. And if you plug in 0 for your x value, you get 2 times -1 times -2. -2, excuse me. -2 times -1 times -2. What is that, -4? Yay, I can math. All right, -4. Good enough. Ta-da! So when it's telling you to sketch, they mean sketch. It is rough. It just said intercepts. It's the only thing to care about. And the last one only has one solution. Its vertex must be sitting right on the x-axis at x equals -2, and the front number is positive, so I'll draw it like this. And if we plug in 0 for our x to get our y-intercept, 1/2 of 2 squared. That's just going to be 2. And this thing's going to be wide, the way I drew it. There it is. No need to get fancy or tell them more than they asked for. The unfortunate thing about IB test questions is, even if you had the right answer, if you keep working, you will talk yourself out of those right answer points. So when you're finished, you're finished. Stop doing stuff. Stinks when a student talks themselves out of points. But all that's easy, right? No one's panicked. Pretty simple. Now this one, we're graphing again, but this time we are in vertex form. So what I'm going to go ahead and do is I'm going to write the vertex. And the vertex is always going to be what makes the inside equal 0, comma the number to the far right. There. Works every single time. You will see that there are test questions that IB likes to mess with the symbols. You need to watch their symbols. For example, nobody panic, I'll come back to it. Down here in vertex form, there was a minus sign right there. But I've seen test questions where they change the generic form to a plus, and then they say, what is the value of h? And they're messing with you. They're looking to see, can you play the double negative game? Well, you can either try to figure that out, or you could beat them at their own game, and you could just write what I just did, put the little v, and then write where the vertex is. And now you're not worried about the symbols. IB likes to play with the symbols. So you guys, you just beat them, and you write, oh, the vertex is at -1, 4, just like that. Okay? You good with that idea? Because watch them. There's some tricky people. Alrighty, and this thing points down, right? So we know where our vertex is, and it says axis of symmetry, which we know is going to be at x equals -1. And the y-intercept, we have to find the y-intercept. So let's figure out where that is. Y equals -2 times 1 squared plus 4. 2. Okay. Points down, crosses the y-axis at +2. And vertex is at, I'm going to have to redraw my lines. I need more space. Necesito más espacio. There we go. Vertex is at -1, 4. 1, 2, 3, 4. It is imperative that you make it obvious what your scale is if you have to sketch a graph. If you do not put numbers on one of your axes, they will not assume what your scale is. Make sure it's obvious. It's clear that I counted by ones. Vertex is at -1, 4. Axis of symmetry goes right through that bad boy, like that. Y-intercept is at +2. Well, what that means is that there's another point right here that's also at +2, because they're symmetric. There you go. Now, if they ask you to graph something and they say clearly label the vertex and y-intercept, this one is clearly labeled, but the vertex is not. It would be clearly labeled if you put this on it. Now it is clear where you wanted that coordinate to be. That's how you clearly label a graph to make sure you get full credit. Yeah, you have to pay attention to what the instructions are. When I say the instructions, I mean what verbs did they use? They play games with the words. All the words mean something different. For example, if you see write down the coordinates of the vertex, that means no work had to be shown. Write down means literally write down the answer. They expect you to be able to see the answer with no work. If they say find, yada, 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 that means they're expecting at least a couple steps of work. If they say sketch a graph, it's obvious, but if they say with clearly label the, you make sure in your graph it is clearly labeled. Next example just wants us to know the vertex. Well, it's in standard form or generalized form, whatever you want to call it. So x equals -b/2a is going to be your axis of symmetry, which is also the x value of the vertex. So we have to start there. Writing x equals -b/2a for a question like this would have gotten you one of your marks. Usually, correct substitution will also get you a mark. So I always show my work just in case I make a mistake. And I have a story for that I'll tell you in just a moment that will not make it onto the record. That's going to go on YouTube. So our vertex is not complete until we plug in that x equals 2. So the y value is going to be 2 times 2 squared minus 8 times 2 plus 1, -7. Yep. So our vertex is at -2, excuse me, +2, -7. Yeah, no, that's what it is. Your work, we were told, because IB grades on a scale of 1 to 7, right? And you're like, you want to know what a 7 paper looks like? It looks like an answer key. That's what a 7 looks like. It looks like you were teaching. That's what a 7 looks like. They're insanely rare. So it says write. Now, this is like straight up and down an IB style question, one of the easy ones. I've seen them like this. It says write this quadratic in this form, and it says by completing the square. That means you didn't have an option. You were told you had to use completing the square. Then sketch the graph stating the coordinates of the vertex. Right, well, hopefully you remember how to complete the square, right? Now for this one, I'm not going to move that 3 to the other side because I'm not trying to solve by completing the square. I'm just trying to convert this to vertex form. So what I'm going to do is I'm going to separate the x squared, the plus 4x, and then I'll take the plus 3 and put it back there. Now we all know, hopefully, that there is a constant that we're supposed to be finding, magic constant that goes right here. Now normally what we would have done is we would have added that c to both sides, right? But we can't do that now because we're not going to do anything to the other side. So what I have to do is make sure that I've actually not changed the equation at all. And the only way to do that is if there's a plus c here, there's also a minus c. See, now I've actually done nothing because the plus c and the minus c would have canceled each other. Do you remember when we were completing the square and I was like, oh, remember that number on the front, if you distributed it? You guys remember doing that? You still have to do that. For example, let's just say for the sake of argument, there was a 3 here and there was a 3 here. Then that would not have been a minus c outside. It would have been a minus 3c. Okay? Or if that was a negative 3, that would not have been a minus c out there. That would have been a plus 3c. Because it has to be, what do I get? What's the opposite of this distribution? Let me erase all that because it doesn't say any of that. There. We need to find magic c. So we take our b value, we cut it in half. So half of our b value is 2. And then we square that number. Gives us a 4. So we know that c equals 4. Like that. Okay. The set of parentheses is now a perfect square trinomial, which factors to x plus 2 squared. Remember that this value here is always your b over 2 term. So as long as you did that math right, it's going right there. b over 2 was 2, so there it is. And 3 and negative 4 makes negative 1. Cool. We have converted by completing the square, and we are now also going to state the coordinates of the vertex, because what's a vertex form? That should be the very first thing we do. Our vertex can be found at what makes the inside equal 0, comma, the number to the far right. Negative 2, comma, negative 1. Time to sketch. It says, sketch the graph stating the coordinates of the vertex. It didn't say anything about the axes intercepts, right? Doesn't even matter. Vertex is at negative 2, negative 1. Picture not drawn to scale because who cares? There's my vertex. And because I've stated it here, I don't have to put it in the picture, but it wouldn't hurt you to do that. Negative 2, negative 1. I know the parabola points up because the front number is positive. And what would make this easy is if I just knew what I'd get if I plugged in x equals 0. And when you plug in x equals 0 to standard form, the back number is always your y-intercept. So positive 3. Like that. And that'll be good enough. I missed the dot, but I missed the point. That's what fat dots are for. There you go. Easy enough. You could if you cared, you could factor it and see where it crosses the x-axis, but they didn't ask you to. So it's not important. But it's not hard, right? I mean, this really is Algebra 1 type stuff, right? It's not bad. Completing the square is not fun for everybody, but it's not hard. Am I good to move? Is anybody panicking? I don't want to move too fast. I mean, I do have 2 days. So what time does this period end? 4 minutes. Let's see what the next example looks like just to see. Ugly is right. We'll start there tomorrow.